Now again, when we have this situation, we need to think back to the fact that when we have forces, we have to deal with vectors. And so this force of 138 times 10 to the 9 newtons is pulling in that direction on the positive charge here. But in order to determine how much of that is in the x and the y direction, how much total force these two place on it, we have to resolve that into vectors. In order to resolve it into vectors, we need to know things like this angle and this angle, which I'll call one of them theta and the other one phi. Angle theta, here's what I know about that. That side's 2 and that side's 3. Therefore, if I draw that little triangle up here, it would look like this. And I'd say, I want to know what that angle is. Well, tangent is opposite over adjacent. So the tangent of theta would be equal to 3 over 2. That means the inverse tangent of 3 over 2 is the operation you do to get theta, and what I got for theta was 56.3 degrees. Similarly, I look at this little triangle right here, and if I redraw that one down here, what's it look like? It looks like this. Well, one side is 1, one side is 5. Again, I want to find that angle, which I'm calling phi. And same calculations I had here, the tangent of phi will be equal to 1/5, or the inverse tangent of 1/5 is equal to phi, and that tells me that phi is equal to 11.3 degrees. Now what do I do with those? Well, if you remember, the y component of the vector quantity is you take the hypotenuse and multiply times the sine of the angle, and the x component, you take the hypotenuse and multiply times the cosine of the angle. So our x and y components are like this. I'll put blue in the x direction here. So that is 138 times 10 to the 9 newtons times the cosine of 56.3 degrees. That's in, I talked about the I hat direction. And that's plus 138 times 10 to the 9 times the sine of 56.3 degrees in the j hat direction. Similarly, for this guy, I've got 345 times 10 to the 9 times the cosine of 11.3 degrees. That's in the I hat direction. Plus 345 times 10 to the 9 times sine of 11.3. But now I look at that sine and say, which way is that pulling? That's down in the negative direction. So this whole thing is just a negative sign because it's pulling in the negative direction. And again, if I rewrite this, so that it's easier to see down here, I multiply those numbers out. F12 is the following. It is 76.6 times 10 to the 9 I hat plus 114.8 j hat. And F13 is 338.3 times 10 to the 9. Oops, I didn't put the times 10 to the 9 here. Minus 67.6 times 10 to the 9 j hat. And so if I want to add those two forces together, which I do, I have the total force on that positive charge. Add these together, I get a 414.9 times 10 to the 9 in the x direction. And over here, it's like 47.2 times 10 to the 9 in the j hat direction. So that's my x component, that's my y component. The total force, of course I can get by doing a squared plus b squared equals c squared and knowing what the total force would be that would be acting on this, and I can get the angle by doing the inverse tangent of those two. So ultimately that's going to be pulling it up, what did I say, 414 and 47, so it's going to be a very, very small angle there. It's going to be pulling in that direction because these two are going to be acting